So this is problem 1.7 in Irodov's book of Problems in General Physics. The problem statement says that two swimmers leave point A on one bank of the river to reach point B, which is lying right across on the other bank. One of them crosses the river along the straight line AB, while the other swims at right angles to the stream and then walks the distance he has been carried away by the stream to get to point B. What was the velocity u of his walking if both swimmers reached the destination simultaneously? And the stream velocity is given to us as 2 kilometers per hour, and the velocity of each swimmer with respect to water equals 2.5 kilometers per hour. So let's see what they're trying to say by means of a diagram. So this is the river, and these are the 2 points on its banks A and B, and they are right across each other, and the river is flowing with a velocity v naught. So the left hand side of this diagram shows the path that is taken by the first swimmer, and the right hand side of the diagram shows the path taken by the second swimmer. So the first swimmer crosses the river along the straight line AB. So basically the first swimmer, he's actually his absolute velocity would be at a certain angle. So this is the angle, but because the river is also flowing in a certain direction with a velocity v naught, so the river is flowing from left to right with a velocity v naught. The velocity of the swimmer then becomes vr1, which is the relative velocity of the swimmer, and we can write down vr1 is equal to v1 plus v naught. So these are all vectors, and v naught, the value of v naught is given to us as 2 kilometers per hour, and the velocity v1 of the swimmer is given to us as 2.5 kilometers per hour. So the swimmer ends up swimming along the straight line AB and goes from A to point B. And similarly, the second swimmer chooses to swim in a direction at right angles to the stream. So his velocity is v2, and then the relative velocity of the swimmer becomes vr2, which is a sum of the velocities v2 and v naught. Again, v naught is given to us as 2 kilometers per hour, and v2 is given to us as 2.5 kilometers per hour. So this is all the information that is given to us. Now we have to find out, so once the swimmer swims, the second swimmer swims from A to B in a direction perpendicular to the stream velocity, instead of reaching the point B, he reaches point C. So this is point C here, and the swimmer goes from point A to point C, and then in order to reach point B, he walks along the banks of the river with a velocity u, and we have to calculate u. So this is what we have to calculate. This u is the velocity that we have to calculate. So how do we do that? We are also told that the total time that they reach, both the swimmers, they reach the point B simultaneously. So let's first calculate the time taken by the first swimmer. So the time taken by the first swimmer would be equal to the width of the river. So the first swimmer ends up swimming along A from A to B. So, and the width of the river is, we assume it to be W. So the time taken would be the distance traveled, W, divided by the speed, that is VR1. Similarly, for the second swimmer, the time taken would be equal to the distance he travels, the distance he swims from A to C. So that is AC divided by VR2. And then the second swimmer goes from C to B at a velocity u. So that would give us C to B. So that is CB divided by u. And we have to find out u. So how do we solve it? We are also given the information that T1 is equal to T2. So our equation becomes W divided by VR1 is equal to AC divided by VR2 plus CB divided by U. Now the angle which the second swimmer makes, this AC line makes with AB, let's call it theta here. So this is the theta angle that AC makes with the line AB, and we have to calculate that also, and we'll be doing that in the next few steps. So first we need to calculate the velocity VR1. VR1 is not, it's not going to be difficult to calculate. VR1 will be equal to V1 square minus V0 square. So if we look at this triangle, this is a right angle triangle here. So VR1 square plus V0 square will be equal to V1 square, and we can use the right angle relation for this. So V1 square is given to us as 2.5 and V0 square is given to us, V0 is given to us as 2 kilometers per hour, so this becomes 4, and we get 2.25, and this is equal to 1.5. So we know that VR1 is equal to 1.5 kilometers per hour. And now we have to find out so this is all we need for the first swimmer. Now let's move on to the second swimmer. So for the second swimmer, first we need to find out AC. And from this diagram we can say that AC is equal to AB divided by cos theta. AB is nothing but W, so instead of so let's okay, so AC divided by VR2, and AC is equal to AB. So we are looking at the right hand side of this equation now. So this is the equation that we got. Let's call it equation 1, and we have solved for VR1, which is on the left hand side of this equation, and now we are solving for the right hand side of the equation. We are simplifying it. So the first term on the right hand side of the equation is AC divided by VR2, and AC is equal to AB divided by cos theta. So that is equal to W divided by cos theta. And AC divided by VR2 would be equal to W divided by VR2 cos theta. Now the second term is CB divided by U. So CB is equal to AC sin theta, and AC is again AB divided by cos theta multiplied by sin theta. So this is equal to AB tan theta. So this is W tan theta because AB is equal to W. So this is CB, and we have got CB divided by U. So CB divided by U will be equal to W tan theta divided by U. Now let us write this equation once again. So our equation becomes W upon VR1 is equal to W divided by VR2 cos theta plus W tan theta divided by U. And we have to find out U in this question. So W, we can divide the entire equation with W and it will cancel out. So we get 1 upon VR1 is equal to 1 divided by VR2 cos theta plus tan theta divided by U. VR1 we have already calculated here. This is equal to 1.5 kilometers per hour. So this is VR1. So we get 1 divided by 1.5, and this is equal to 1 divided by VR2 cos theta plus tan theta and U. So now let us look at so we have quite a few unknowns on the right hand side of the equations. We have VR2, we have cos theta, tan theta. So once we find out theta, we can find out cos and tan theta. So let us look at this triangle here. So we need to find out VR2, and in this case VR2 will be equal to under root of V2 square plus V0 square. So this is also a right angle triangle formed by V2, V0 and VR2. So these three. So we can find out VR2. So VR2 square will be equal to V2 square plus V0 square. V2 is given to us as 2.5 kilometers per hour. That is 2.5 squared plus V0 squared is again 2 squared. So if we have to find out VR2, this is going to be 6.25 plus 4 under root of 10.25, and if we calculate it, we get the value of VR2 as 3.2. Now once we have calculated VR2, we need to find out cos and tan theta. So again, let us look at this diagram here. So let me just redraw this diagram over here for the second swimmer. So for the second swimmer, the swimmer is swimming in the direction which is at right angles to the direction of the stream or river, and this is the diagram here, and theta. So we have to find out theta. So theta is or cos theta and tan theta. So cos theta would be equal to V2 divided by VR2, and V2 is given to us as 2.5 divided by VR2 is given to us as 3.2. So when we solve it, we get the value of cos theta would be equal to 0.78125. And again for tan theta, in this triangle here, tan theta would be equal to tan of an angle in a right angle triangle is given by perpendicular upon base. So the perpendicular is V naught, which is the side of the triangle that is opposite to the angle. So V naught divided by V2. So V naught is given to us as 2, which is the velocity of the river, and 2.5, which is the velocity of the swimmer, and this is equal to 0.8. So these are the values of cos theta and tan theta. Now we can substitute these values into this equation here. So if we substitute these values in this equation, what do we get? We have gotten VR2. We have solved for cos theta, tan theta. The only thing that remains unsolved is u, and we can put these values in this equation to find the value of u. So let's do that in the next few steps. We get 1 divided by 1.5, and this is equal to 1 divided by VR2 cos theta. So 1 divided by VR2, we calculated VR2 as 3.2 in this equation here. So 1 divided by 3.2 into cos theta is 0.78125 plus tan theta, which is 0.8 divided by u. So 1 divided by 1.5 will give us 0.67. And this one, if we calculate it, we get a value of 0.4, and this is 0.8 divided by u. Now if we solve this equation, we get 0.27 is equal to 0.8 divided by u, and u will be equal to 0.8 divided by 0.27. This will give us a value of 3 kilometers per hour. So the second swimmer will have to walk at a speed of 3 kilometers per hour when he walks from point C to B. So as he walks from point C to point B here, he'll have to walk at a distance of 3 kilometers per hour so that they both reach simultaneously. So this was the 7th problem in Irodov's book, and thank you for watching. And if you like the content on this channel, please like, share and subscribe this channel. Thank you very much. Have a nice day.